Hi, I'm Sam Gottlieb, physics student extraordinaire. Now today, for part one of our problem, we need to calculate the acceleration of the dragster. Now the first step to this is to calculate the distance of an individual color section and then multiply the distance of the color sections to find the distance the dragster accelerates. So if you'll join me, it's quite tedious.
If we start counting colored sections from where the cart begins to where it ends at the 120 sign down here, there are 10 different colored sections.
Oh, hey there, you're back. So I just determined that one section is 37 feet, and there's 10 sections that the dragster is accelerated over, making the total acceleration distance 370 feet.
Part 5 of this problem requires you to know the height of the track above the ground. So Udit is measuring the height of the track with this ruler. We will then convert from inches to meters in order to use it in the projectile equation.
Alright, so we're going to use a kinematics equation. V squared equals 2ax to calculate the average acceleration. So we know the final velocity is 120 miles per hour. We're going to convert that to meters a second.
Miles per hour. Okay.
How many meters are in a mile?
Divided by, what's the distance? 370 feet.
Alright, so we calculated average acceleration over the acceleration of the top fuel dragster using the kinematics equation v squared equals 2ax. So we calculated our final velocity at 120 miles per hour, converted that to 53.6 meters per second. The distance acceleration occurred over was 370 feet. Turns out that's 112.77 meters. And so we plug that into the equation to get 12.7 meters per second squared is our average acceleration. Divide that by our gravity, which is 9.8 meters per second, which gives us 1.3 Gs as our acceleration.
So then EK equals 1/2. Oh, we didn't find mass. What are we going to say for that? Okay, so for number 2, we were asked to find the efficiency of the ride. So to do this, we find the potential energy at the top of the hill over the kinetic energy at the beginning. So to find this, we end up putting potential energy, or gravitational potential, or MGH, over the kinetic energy, 1/2 mv squared. The masses cancel, showing that, moving on, it gives us the gravity times the height over 1/2 v squared. And then once we plug in all the values that we have, we get a value of 86% efficiency.
So we previously found the height to be 420 feet. When we convert that to meters, we get 126 meters. Using the kinematic equation, x equals 1/2 at squared, and we substitute 126 meters for x and 9.8 for a, we end up with a time of 5.1 seconds. So using our picture for scale, we determined that the diameter of a wheel is equal to 40 centimeters, or 0.4 meters. If you multiply that by pi, you get the circumference of a single wheel, which is 1.26 meters. The amount of rotations that the wheel completes in a given distance is equal to distance divided by circumference of the wheel. If the distance of the track is equal to the height of the track, 126 meters, and the circumference is 1.26 meters, we get that the wheel completes 100 rotations by the time it reaches the top.
Next problem, we're calculating how long it takes a screen to travel from the top of the dragster to the bottom. So we know the speed of sound is 343 meters per second, and the height of the hill is 126 meters. Using the equation x equals vt, we find that it takes 0.37 seconds for the sound to travel. Now we want to find out, since the cart's going down the hill now, how fast the cart's traveling at the time the sound reaches the bottom of the hill. So we know v equals at, the acceleration is 9.8 since the cart's in free fall. So we'll multiply 9.8 by 0.37 seconds to get 3.62 meters a second.
For this question, we are asked to find the horizontal displacement after the track is stolen. So to do this, we use the formula x equals 1/2 at squared, and we know that we found the height the height of the track by measuring it, and then with that we plug it into the formula x equals 1/2 at squared, and we solve for t. Here we find the time equals 0.8 seconds. We then use this time and multiply it by the velocity to find the horizontal displacement, which we find to be about 40 meters.